My machine learning course project in this video. As the title says, my work tries to build a better approaches for stock prediction in the long term using fundamental data. So in general, people they have used various data sets based on their duration to catch to basically predict the stock trends. Like using historical data of the stock prices, we may predict trends which is a short-term based approach. In the medium run, the stock prices may vary because of the company's reputation and its presence in the social media. So, using some natural language processing, we can build some deep learning models to predict stock prices. However, in the long run, we have to expect a company's market value to reflect its financial performance, which is captured as fundamental data, like that is income, revenue, assets, dividends, debts, etc. Share and we say like shares reflect ownership in a company, and thus shares prices should ultimately move towards company's intrinsic value. So in my project, I've tried to incorporate fundamental data as an important input parameter to predict the stock price, and I've compared I've compared a univariate LSTM based model which predicts based on stock prices as a single input, and with the bivariate model which takes historical stock price data along with the stock market index value. And the main model which I've put focus on like is the fundamental parameter which basically takes fundamental parameters also as the input feature. So, so my course is basically motivated mainly from these two papers. The first one is Pharma and French. So they performed a time series regression of returns with fundamental factors. They investigated factors affecting market beta, which is the measure of volatility of a security in comparison to the entire market, and established that firm market capitalization and book to market equity are able to explain most variations in returns. They created a chart based on book to market ratio size and the size of the firm, and concluded a negative relationship between the size of the firm and the returns. The other paper basically projected companies' fundamentals and attempts to use these to compute value factors based on the future fundamentals. So my data set for the fundamental data set, I contacted Wharton Research Data Services (WRDS), which is the most authentic data set available for market analysis, accounting, finances projects. However, my request was rejected because they told me like it is only available to the research lab and the professor's guidance. So I used the database from stockpups.com, which has fundamental data available for about 700 companies, out of which I chose oil and gas sector companies, which were having more than 20 years of data like continuously. So I could select only 16 securities in my particular field. So for stock price and market index, I referred the Yahoo Finance website to download daily data for about 20 years. So I use this methodology basically to like doing the daily average price is calculated from the price data from the open, low, high, close, like four parameters from the Yahoo index, and then I did a monthly average for this from this daily average price, and used it against the fundamental data set. Like fundamental data set is available quarterly, so I used a linear interpolation to make it monthly to, and then I use an LSTM model to basically predict the final price of the stock. Did some tuning and optimization of hyperparameters, and then I calculated these results. So these are the root mean square errors for different models for like these 16 securities. So my results will be like, if I want to conclude, the average percentage RMSE of for multivariate cases like 54.1%, bivariate comes around 57.4%, univariate is 46.3%. So out of these 16, multivariate model basically outperforms univariate like in about 8 cases. For example, like in case of DO, NBL, RRC, SWN, HP, NFX, CWX. Bivariate model, like it gives better results than the univariate, like in about eight cases. So, however, this project work could not establish that deep learning models combined with the fundamental factors improve the prediction accuracy significantly. But my conclusion would be, since I did not use a very authentic database, very reliable database, my results might be having higher RMSE. Uh, Second reason would be that French and pharma model, they stated a negative relationship between the farm size and returns. So here too, in my results for companies which have higher market capitalization, which are part of S&P 100, for example CVX or XY, etc., they have generally low RMSE, which is less than 30%. So I could conclude, since most of the companies selected in my portfolio, my project are smaller companies, we may be getting very high overall root mean square error. So I think this would be my complete conclusion. Thank you very much, Professor, for this wonderful class and for a lot of learning from you. If you have any questions, please, regarding my project, I would love to answer you. Thank you very much.